the general definition of error is difference between the ideal output minus the actual output. This definition is generally true, but we have already seen that in control system, we assume the input signal is actually the ideal output signal. That's why we are having the equation Laplace transform of the error signal is equal to Laplace transform of the input minus Laplace transform of the output. But there is one more error which is named as actuating error signal. To understand what is actuating error signal, let us first consider a unity feedback system. Now there are two positions, position 1 and position 2, from where we find two different errors. The error we just talked about, ES, is calculated at the output terminal, or we can say at the position 2, and this is the same error with the help of which we find the steady state error. However, there is one more signal which is calculated just after the summing junction, which is represented as position 1, and that error is referred as actuating error signal. Let us see the expression which will come out for the actuating error signal in this unity feedback system. From the diagram, we can simply say that C is equal to A minus V, and C is nothing but actuating error, A is the input signal and B is the output signal. You can see the expression for error signal and actuating error signal are both exactly the same for unity negative feedback system. And that is the reason why in previous lectures where we have seen steady state errors for unity feedback systems, I have represented the error signal at position 1. However, the real problem comes when the system is non-unity feedback system. Here, if we calculate the actuating error signal, then we will see the expression has slightly changed. So, the first point you have to remember is that the definition of error signal is universal. It is same for positive feedback system, negative feedback system, unity feedback system, as well as non-unity feedback system. It does not matter what type of system you are having, the definition for error signal will remain same, and it is calculated at the output terminal only. And we have already seen how to convert a positive feedback system into a negative feedback system, as well as how to convert a non-unity feedback system into a unity feedback system. The one common misconception students usually have is that this expression for error signal come from negative feedback system at position 1, which is wrong. This is actually the definition of error signal and has to do nothing with the block diagram. In the previous lectures, even I have used position 1 to represent the error signal, but I have done that just for simplicity. However, before moving forward, it is very important that you clear all your concept. On the other hand, the expression for actuating error comes from the block diagram only and is different for different types of system. The expression for actuating error will change for positive feedback system, but that is not true for the error signal. Now let us find the expression for actuating error for non-unity feedback system. We can write the Laplace transform of the output signal is equal to Laplace transform of the input signal multiplied by transfer function of the system. By putting this value and after rearrangement, we can find the expression for actuating error signal of a non-unity feedback system. And by simply putting Laplace transform of the feedback function Hs equal to 1, we will get the actuating error signal to be equal to Laplace transform of the input signal divided by 1 plus Laplace transform of the feed forward function, which is exactly equal to the error signal which we have already derived in earlier lectures. This is the main reason why most students gets confused. They don't know what is the difference between actuating error and error signal. This happens because most of the textbooks which are meant for undergraduate level studies consider only unity feedback systems and cover all the topics considering only unity negative feedback systems. In such cases, both the error and actuating error has equal value. That's why students generally don't get the idea that they are actually different parameters. The problem arises when the system is non-unity feedback system. Suppose in an interview you are asked which error we can represent at position 1 in the block diagram of unity feedback system, then you should not be telling error signal. You should clearly say that at position 1 we represent actuating error signal. However, for unity feedback system, actuating error signal is exactly equal to the error signal, so we can also represent error signal at position 1. let us sum up and conclude our lecture. The definition of error is ideal output minus actual output, which is a general definition. In control systems, we have two different terms, error and actuating error signal. Error signal is computed at the output side, whereas actuating error signal is computed just after the summing junction. The actuating error formula is actually same for unity and non-unity feedback system. However, the formula changes for positive feedback system. We can also find steady state actuating error by putting the limits s tends to 0. Likewise, we are having error signal formula as well as steady state error formula. But here we have only one formula which is meant for unity negative feedback system. If we are having positive feedback system, then we have to first convert it into negative feedback system. And the same way, if we are provided with non-unity feedback system, then first we have to convert the system into a unity feedback system. Try to derive the formula for actuating error signal for positive feedback system. You can take help from the short notes which I have attached in the video description. The bottommost link is of the current unit.